going to talk about independent and dependent events. So continuing on, talking about probability. Section 11.3, talking about independent and dependent events. Independent events. Two events, A and B, are independent if the occurrence of one does not affect the probability of the occurrence of the other. When you think of independent, in science a lot of times you think of like an independent variable, right? What's an independent variable in science? Stands alone, stands by itself. Same is true for independent events and probability. It's an event that stands alone. It is not affected by anything else. Okay, it is of itself. For example, case 1 here. A card is drawn from a deck and then placed back in the deck. So a deck of cards is made up of how many cards? 52. So if I draw a card out of the deck, place it back in the deck, does the deck change at all? No, so that's independent events. The deck does not change. Another example a lot of times they use is like flipping a quarter and rolling a dice. Does flipping a quarter have any effect on what happens when you roll the dice? No, those are two uniquely different probabilities. Those are independent events. Whereas case 2 here, a card is drawn from a deck, it is not replaced. So if I draw a card from the deck and do not replace it, does my deck change? Yeah, that is not an example of independent events. That would be an example of dependent events, which we'll talk about here in a little bit, actually. Okay, so again, notice the difference. Independent, they stand alone. They're each unique in themselves. Dependent, the second one is dependent on the first one. So multiplication rule for the probability of independent events. A and B are independent events. Well, to find the probability of both events happening, you find the probability of A, you find the probability of B, and then you multiply the two events. And this is the key. A lot of students, don't ask me why, always want to add the probabilities. Okay? When you have two uniquely different events, you need to multiply them. Okay, so example here. A deck of cards has 12 face cards. Face cards are Jack, Queen, King. And 40 number cards. A card is drawn from a deck and then placed back in the deck. A second card is then drawn. So the card is drawn, looked at, placed back in the deck. Deck does not change. Independent events. What's the probability of drawing two face cards from the deck? Well, probability of drawing a first face card is 12 out of 52 or 3 out of 13. Probability of drawing a second face card is the same because the deck does not change. So probability of both of those things happening is 9 out of 169 because they multiplied those two. All right, and then we can do it another way. We can find the probability of drawing a face card and then a number card from the deck. So a face card and then a number card would give me a bigger probability. Okay, so again, on these questions, you got to ask yourself, is it affected or is it not affected? Because it changes your second probability or not. So let's look at number 1. Ben rolls a 4 and then a 5 on a 1 through 6 number cube. What's the probability of him rolling a 4 on the cube, Andy? What's the probability of him rolling a 5 on the cube, Andy? Okay, I have two unique probabilities. What do I do to find the probability of both those things happening? I need to multiply. So 1/6 times 1/6, the probability of both of those things happening would be 1 out of 36. Nice job. Number 2. What's the probability that Ben rolls a 3 and then an even number on a 1 through 6 number cube? So what's the probability of him rolling a 3, Mr. Lakin? What about getting an even number, Mr. Monahan? 1/2. I have each probability. Now what do I need to do with them? I need to multiply. And I get what, Miss Worth? 1/12. Nice job. That is the probabilities there. All right, so that's independent events. Each one is unique of itself. Next thing we're going to talk about is dependent events. So two events, A and B, are dependent if the occurrence of one affects the probability of the occurrence of the other. For example, a card is drawn from a deck and then it's not replaced. Now again, dependent events you've really got to think about. For instance, let's say I'm drawing a face card from a deck. What's the probability of me drawing that first face card? 12 out of 52, right? If I leave that card out, What's the probability of me now grabbing a second face card? 11 out of 51. Why is it 11? Because that face card is out and I have one less in that deck of cards. And that's the biggest thing with dependent events is you need to think about what are you pulling out. Okay, or what are you leaving out? And here's an example. I think it's the same example we just, they did face card and, they did number cards. No, they did face cards. There we go. A deck of cards has 12 face cards and 40 number cards. A card is drawn from a deck and then not replaced. A second card is then drawn. What's the probability of drawing 2 face cards from the deck, like we just talked about? Probability of that first face card is 12 out of 52, or 3/13. Probability of the second face card is 11 out of 51. Again, why is it 11? Because that face card is still left out. Okay? And then what's the probability of both those happening? Well, I would still multiply them and then simplify, and you get your final probability. Okay? Notice, what happens if I were to draw a face card and then a number card? Does the number card, are the number cards affected? If I leave a face card out, are the number cards affected? No, so there's still 40 number cards, but how many cards are in the deck total then? Still 51 cards in the deck there. So recognize, when is the numerator affected and when is the denominator affected for when you're doing those probabilities. That's very important in this. Let's try number 3. Draw 2 number cards without replacing the first card. So in deck cards, what's the probability of drawing the first number card? How many number cards are there? 40. So 40 out of 52. Or I could say that is the same as 10 out of 13. In cards, always look to simplify right away. Just divide it by 4. Ace or hearts, diamonds, clubs, spades, right? Just divide by 4 and you get the probability usually. What's the probability of getting a second number card without replacing the first one? So what's the probability of grabbing a second number card now? 39 over 51. Nice job. Now, what's the probability of both of those things happening? Well, I need to do what? Multiply. 10 out of 13 times 39 out of 51. You'd want to multiply those. When you multiply those, you get... What did you say? 390? You get 390 over, did you say 663?
Yeah.
Nice job. And that can be simplified. I think both those are actually divisible by 13.
Get 51 for 663.
51 over what?
No, 51 on the bottom.
51 on the bottom?
Yeah.
And what's on top? 30?
Yeah.
So the final answer would be 30 over 51. Again, the key there is that second one is affected. It's dependent. Let's try number 4. You draw a number card and then a faced card without replacing the first card. So what's the probability of drawing a numbered card from the deck? What'd you say?
40 over 52 or 10.
40 over 52 or 10 over 13. Nice job. What's the probability of now drawing a numbered card given the face card is out of the deck? What's the probability of drawing a number card now? Face card, sorry. Yeah, what's the probability of drawing a face card? 12 out of 51. There's 12 face cards left. I have 51 in the deck now. And now what do I need to do with my probabilities? I need to multiply. So when I multiply them, I get what then, Mr. Melody? 120 over what? 663. Great job. And then that can be simplified. I think both those are divisible by 3 for sure.
So just 40 over 300.
221?
220,
40 over 221? I think that's as far as it goes. Nice job. Again, the key is that second one is dependent. It's affected. Okay, taking all this information now. Try numbers 5 and 6. These are talking about same probabilities. Okay, same probabilities. Try these two. All right, so let's look at number 5 here. What's the probability of selecting 2 apples when they are chosen at random without replacement? What's the probability of grabbing that first apple, John?
3 over 8.
What's the probability of grabbing a second apple then, Mark?
2 out of 7.
And what's the probability of both those things happening then, Mr. Stefaniak?
3 out of 28.
3 out of 28. Nice job, sir. Good simplification. Number 6. What's the probability of selecting an orange, then an apple when they are chosen at random without replacement? Phil, what's the probability of grabbing that orange? What's the probability of grabbing an apple then, Andy?
3 out of 7.
And what's probably both those things happening then, Jack?
6.
Yep.
56.
15 out of 56 is correct. Nice job. Next thing we're going to talk about is you can use tables, interpret tables to find probability as well. So for example, a student must have a B average or better for all courses to qualify for any athletic team at Jefferson High School. The table below shows the distribution of students' grades in 3 sports at the school. So first thing you need to do is always find what? Find the all right. So what do I need to do first? I need to find the total number of people here, right?
Yeah.
So how do I find the total? I could just
Add everything.
add everything up. So what's the total number of people here that they are checking out? 60 what? 63. Nice job. Okay, so there's 63 total. So what's the probability that the student is a field hockey player with a B average? So if I look at field hockey, B average, how many is that? 4. So that's 4 out of 63, which is approximately what, Mr. Stefaniak? I thought I saw you punch it in.
Yeah, came up as 4 out of 60.
As a decimal?
Wait, that as a decimal.
Yeah. Go to the 100th place.
63. 063.
Oh,
You said
so
100.
.06. There you go. I think I meant .63. I was like, no. .06. There you go. I got you. So that's approximately 6/100ths of percent there. Number 8. The student has an A average and plays football. Well, what's the probability that the student has an A average and plays football here? What's that one, Mr. Mario, as a fraction? So that's 2 out of 63. Which is approximately what then, sir? 0.03. Thank you. And then what about number 9? The student has a B average and does not play football. So it has a B average and does not play football. Which ones are we looking at here? 17 out of 63. How'd you get 17, Miss Worth? Yeah, 13 and 4. So 17 out of 63. Great. And that comes out to be approximately what, Mr. Croft? 0.27. Nice job. Okay, so that's probability using tables as well. Last one. Try these 2 problems. Are they independent, dependent, and then find the probability. All right, number 10. Are these events dependent or independent? So there are 4 green marbles and 3 white marbles in a bag. A white marble is randomly selected and not replaced. Then a green marble is randomly selected. Are the events dependent or independent? What do you say? They are dependent because it is not replaced. So what's the probability of this event occurring? Well, what's the probability of grabbing that first white marble, Andy?
3 out of 7.
What's the probability of grabbing a green marble then, John?
5, 6.
And what's the probability of both of those things happening then? Sean?
2 over 7.
2 out of 7. Nice job. Good simplification. 2 sevenths is correct. And that's it for today. There's your assignment.